Yes, eventually we will. Let's look here at these 30 problems though. Okay, it says, number one, it says draw the graph of each linear and then estimate the solution. Guys, the reason it says that is because it gives you two equations. It says x plus y equals 3 and 3x minus y equals negative 11. If you're going to graph those, what do you need to solve them for? Which is it, x or y? Do so. What's y equal to? So negative x plus 3, you go to the 3, and then your slope is up and to the left or down and to the right. Doesn't matter which way you look at it. So there's y equals negative x plus 3. All right, so now I've got to graph negative y equals, move this over. That gives me negative 3x minus 11. Divide by negative 1. And watch this. Y equals 3x plus 11. I end up with an equation. As I end up with an equation, 11 is off my graph. So another thing I might be able to do to graph this one is to find the x-intercept. How do you find the x-intercept of an equation? That's right, you make y 0. So I would take this equation right here and get 3x equals negative 11. So x is negative 11 thirds. That's negative 3 1/3. So what I know is, whatever this solution is, it looks like it would be negative 3 1/3 right there. Then the equation has a slope of 3. So up 3 and over 1 would be somewhere like right in there or something. And so I got an equation here. It looks like negative 2 something. As I can't really tell. I can't tell where these two lines cross at. So even though it asks me to graph it, guys, on the ABCD answer, on a multiple choice test, it may make more sense that you solve the system out. And this is what I can't get some of you guys to do, this kind of thing, where you get 4x equals negative 8, x is negative 2. So this thing should be crossing here at negative 2 somewhere. And so it looks like y, if x is negative 2, y is, let's see, x was negative 2, so y would be 5. So negative 2, 5. So while this thing doesn't cross exactly at negative 2, 5, I got kind of close to the answer right there, so you would be able to pick that out. The point I'm trying to get you to see is if you plug negative 2, 5 in right here, it solves this equation, and negative 2, 5 solves that equation as well. 3 times negative 2 is negative 6, minus 5 is negative 11. So while it asked me to graph it, guys, graphing didn't work out so well. Graphing doesn't work out very well on the next one either. Guys, tonight I won't be online until later, but what I'll do is I'll walk in and I'll log on to Google. And if you want to email me, you got a question or something like that, you can email me at rthill3@gmail.com. For those of you that know how to use Google Chat, you can do that. Or just email me there, and I'll set it up for us back and forth. Well, Jeremy is, but anyway, the other night I was at the football, the Gwinnett County football banquet, and I got a message on there, and I answered a girl's question that she studied the final exam. I had her last year, not even this year. As it doesn't take long, it can help. You got a question, you can take a picture. You can take a picture of the question and send it to me, and I can answer it back. I'll be here before school, after school. See, this is 6th period, so ours will be Friday, yes? So I'll be here before and after on Thursday, Wednesday too, but you're more than welcome to come in and let me answer any questions for you. Okay? Number 2. Guys, number 2, again, is just two equations, 2x minus 3y equals negative 5, and 5x minus 2y equals 4. Again, you want to solve these by graphing. The question says graphing. But it may not make the most sense because when you try to solve this by graphing, look what happens here. You get negative 2x minus 5 divided by negative 3 divided by negative 3. 5/3, guys, that's an estimation. So 2/3 x plus 1 2/3, that's 5/3. So I'm just kind of guessing at where 1 2/3 is. My slope is up 2 and over 3, so I count up 2 and right 3. And so again, I'm estimating where that's at. If I graph here, negative 2y equals negative 5x plus 4. Y is 5/2 x minus 2. First place I go is negative 2. 1, 2, 3. 1, 2, 3. 4, 5, 1, 2. Looks like I got a place where they intersect at of 2, 3. Don't just go now to the ABC answer and guess 2, 3. Know that 2 times 2 is 4, minus 3 times 3 is negative 9, 4 minus 9 is negative 5. Know that 5 times 2 is 10, minus 2 times 3 is 6, 10 minus 6 is 4. So this point solves both equations, which means it has to be correct. Has to be. Anybody? All right, the next question deals with the types. Remember, there's 3 types. There's 3 types of systems. The 3 types of system are a independent system where the lines cross, a inconsistent system where the lines don't cross, and a dependent system where the lines are on top of each other. If you look up here, and again, as this video will be right in the middle of my page, my home page, you can read this a little bit easier if you got access to it and can zoom in. Notice this says the slopes are the same. So they have same slope, different y-intercept. These guys don't cross. Why don't they cross? They're parallel. Why are they parallel? That's right. They have the same slope and a different y-intercept. Parallel. These two have different slopes. Guys, if 2 lines have different slopes, that means they have a solution. They have a solution that's made up of 2 points, an x and a y. So guys, if you want to look at an equation, and answer those questions, then you got to be able to compare the slopes and the y-intercepts. So what you would need to do to both of these is you would need to solve them both for y. However, if you take a close look at this one, right off the bat, you ought to know the slope of that one is 1/4 and the slope of this one is negative 3/4. Because anytime you have an equation in standard form, you can always find the slope by taking the opposite of the equation. So if this is x minus 4y equals 2, the slope is 1/4. It's minus here, so the slope is positive. Here is a positive, so the slope is negative. So right off the bat, this one's independent. Again, guys, notice that an independent system is a system that has a solution. It either has one solution or it has infinitely many solutions. Now, second semester, at the end of the school year, that won't be necessarily the case, because at the end of the school year, we're going to do systems of equations, but we'll do them with lines and parabolas. Think about a parabola. A line might intersect it in 2 places. How about this? We'll do a circle and an ellipse. They might have 4 solutions. So we'll work systems that have more solutions next semester. But where we're at right now, guys, a system is either one of these 3 things. How do you find out what it is? As you take, and I have a problem that's got fractions in it, so I'm going to multiply everything by 6. When I multiply everything by 6, that gives me 3x minus 2y equals 2. Not 2. Where did I get that from? 12 minus 12y equals 2. And then look what my other equation is. My other equation is 3x minus 12y equals 2. So really and truly, these two lines are the same. They're the same. That's called dependent, a dependent system. Consistent means solutions. That's why this one here and this one here are consistent. They have solutions. This one, dependent, has infinitely many solutions. Independent has one solution. Again, as we were going through this chapter, it has one solution made up of how many parts? 2. It's made up of an x and a y. And what does that x and y do to both equations? Nobody? That's not a great question, but you gotta be able to answer it. As the x and the y solve both equations. So the way you find out that a point is a solution to the system or not, you just plug it in. Let's plug 2 in for what? X, and plug -1 in for y. And if this x and this y, 4 minus 6 is -2, it works that equation. And then 2 minus 2 is 0, but it doesn't work that equation. Therefore, it's not a solution to the system. Again, guys, here's me setting up a word problem for you. I've already kind of got it worked out, so I can just talk about it. I got a word problem that's made up of 2 different types of counting. Quantity, which means what? What does quantity mean? How many? And quality means how much. So I got a way to count these things in their quantity, which is x plus y equals 1500, and their quality, which is 12x plus 6y. So 12x plus 6y equals 16,200. So I got a quantity statement and a quality statement, and I multiplied the top one by 6, so they cancel out. And it's 6x equals 7,200, so x is 1,200. Again, here's the part I'm having a hard time getting some of you guys to understand. Check it. Guys, your answer works. I have a student in my first period class who, on the written response that we took, guys, the one where he had to do it by using matrices, he couldn't make the matrices work out. He worked it. Spent the whole time, he spent an hour on that one question that dealt with matrices. So he just wouldn't let it go. Kept trying. Some reason or another, he had a 1 and a 2, like transpose. He had the 1 in where the 2 was supposed to be, and 2 in where the 1 was supposed to be. So he kept getting it wrong. He kept at it, and he did it a couple other ways and figured out, and then finally he said, I can't see. So all I did was point to him. I said, what's that number supposed to be? And it came to him. Guys, that's what you got to do. He knew what the right answer was because he had taken, look, guys, it works out. 12,000 times 12. 1,200 times 12 is 14,400. 6 times 300 is 1,800. You add those two together, it gives me 16,000. 200. 300 plus 1,200 is 1,500. It works. As word problems are tougher sometimes, but they work. And then again, even though the problem doesn't say, it doesn't give you a choice to solve this system by using matrices, there's no reason why you wouldn't do every single one. Look, 1, 1, 12, 6. 1, 1, 12, 6. 1,500, 16,200. Write A inverse in your B in your calculator, plug it in, hit enter, bang, it'll be right. Now, all that time you saved, use that time to check a problem and see if you're doing it right. Okay, there's a bunch of different problems here. I don't necessarily want to work through each one of them, but just kind of give you the idea of what we'd be able to do. Because really and truly, guys, you guys are still using me to check your work. You're just not being very diligent as a student because you don't need me to check your work. Guys, make everything negative. 3y equals 6, y equals 2. Take that 2 and plug it in. 3x plus 8 equals 4. Let's see if I'm sorry, negative 6. So y equals negative 2. So this will be negative 8. So when I add 8 to the other side, 3x equals 12, x is 4. Guys, 4, negative 2 works both equations. If whatever you did as the answer doesn't work both equations, then you're doing it wrong. These little systems like this, y'all can't miss those anymore. The time that you would miss that, guys, is gone. You'll never miss one of those again unless you choose to. And by choose to, I mean you just don't take the time to check it. Because again, 4, 5, 3, negative 5 is A, 622 is B, A inverse B, hit enter, go to the next one. Work on something else. Because this is the kind that are a little bit more interesting to us. Now, what's cool about these, look at this. What's cool about these is if you eliminate something, if you add them together, add those two equations together right there. That gives me negative x minus 3y. Look, the z's cancel out, equals negative 1. So I've used this equation. Now I'm going to use this equation and this equation. I'm going to add them together. 2x minus y equals negative 5. What does this look like? What does this right here look like? That looks like one of those problems, doesn't it? That's it. Look, guys, that's how you do it. If you have a 3 by 3 matrix, what you want to do is reduce it to a 2 by 2. If you had a 4 by 4 matrix, the first thing you would want to do is make it a 3 by 3. Then when you have a 3 by 3, make it a 2 by 2, so on and so forth. Multiply through by 2, gives me negative 2x. Multiply by 2, that gives me negative 6y. Multiply by 2, that gives me negative 7. So negative 7y equals, negative 2. Negative 7y is 1. What do I do with that 1? Plug it in. Pick an equation, guys. It looks like this one would be the easiest. 2x minus 1 equals negative 5. Add 1, 2x equals negative 4. Divide by 2, x is negative 2. Go to the very top equation. Look, it's the easiest. It's the easiest one. Take that x, that y, plug them in, solve it out. X is negative 2 plus 1 plus z equals 5. So z equals 6. Is that right? Negative 2 plus 1 is negative 1. Add 1, so that gives you z is 6. So my answer would be negative 2, 1, 6. Y'all remember how those graph forward, backward? What was what? Right, but what was that? What was the first way we went? Okay, but it's a negative, so we go back 2, right 1, up 6. Yeah? You know what we did? We went forward or backward. We went right or left. We went up and down. So on the graph, I went like that. I went right 1, and then up 6. That's how you drew your little 3 and 6. I'll look at those more tomorrow. Again, if there's something specific you want to ask me about that, guys, I do it the same way. Take these two, add them together. Gives you a new equation. Take these two right here, take this one right here and this one down here. Add those two together. 2x and 3x is 5. 5x plus 2y. Take these two and add them together. X plus x is 3x plus 4y. The z's cancel out, and then you have 2 by 2 equation. Systems. Shouldn't be a big deal. All right, inequalities. Got to be a couple of things that we can review here. Something that we can review. Nobody? What's the first most important thing that you got to remember if you deal with inequalities? If you divide by negative, anybody? What happens when you divide by negative? Sign flips, you know that? So what else we got? We got greater than or less than is dotted. Remember that? Dotted or an open circle or parentheses if we're talking about interval notation. Greater than or equal to, less than or equal to is solid. Or if we're talking about interval notation, we use brackets or we use a closed circle. So what I do in these right here, guys, I have 3 graphs I got to graph. I got to graph y equals negative x plus 4, and it's a solid line. And then I'm going to shade, that's less than, so I'm going to shade below that line. So I'm going to go below this line right here. Then I have y is less than or equal to 2x plus 4. So there's that, up 2 over 1, up 2 over 1, and it is below that line. So as of right now, I'm below the black line and below the red line. So my third equation is y is greater than or equal to 2, and that's a horizontal line, and it's above a horizontal line. Answer? Yeah, right there in the middle. That little triangle in the middle. Again, in number 12, you need to solve it for y. So you're going to have a line that has negative slope. Don't forget here in number 13, guys, in 13, if you've got x is greater than negative 3, that's a vertical line and it's dotted. So that's dotted and greater than is to the right. Every once in a while I'll have somebody mess this one up because of the greater than negative 3. They won't think about where the numbers are greater than negative 3 at. That's to the right. So y is greater than or equal to 1 is a solid line. And so again, the answer to the above this line and the answer to the right of that line, because they're both greater than, is this area right here. And so if I pick any point in this area right here, it would solve both equations. That's what you're looking at. And then this one would be 3 equations. Okay. Anybody? Let's stop right there. Let me show you what I want you to do.